Hey there, science fans! Welcome to another exciting episode where we explore the wonders of everyday life. Have you ever jumped on a trampoline? It's not just fun, it's a fascinating example of physics in action. The springs in the trampoline stretch and compress, storing and releasing energy, which propels you into the air. Or maybe you've enjoyed a scenic drive in a car. The smooth ride you experience is thanks to the car's suspension system, which uses springs to absorb shocks from the road, making your journey comfortable. You've experienced the magic of springs in action. From the suspension in your car to the toys you played with as a child, springs are all around us, making our lives easier and more enjoyable. Springs are everywhere, from our pens to airplanes. Think about the click of a pen. That's a spring at work. And in airplanes, springs are crucial for landing gear, ensuring safe takeoffs and landings. These coiled wonders are more than meets the eye. They come in various shapes and sizes, each designed for a specific purpose, from tiny springs in watches to massive ones in industrial machinery. They hold secrets about the fundamental laws of physics, work, and energy. Springs demonstrate Hooke's law, which describes how the force needed to extend or compress a spring is proportional to the distance it is stretched. Let's dive in and uncover the science behind these everyday wonders. First, let's talk about work and energy. Work is what happens when a force makes something move. Think of pushing a swing. You're doing work. Energy is the ability to do work. It's like the fuel that makes things happen. Springs have a special talent. They can store energy. Imagine stretching a rubber band. You're putting in work, and that work is stored as potential energy in the stretched rubber band. This stored energy is just waiting to be unleashed. Section 4. Bowing, from potential to kinetic. When you let go of the stretched rubber band, what happens? Bowing. The rubber band snaps back with a sudden burst of energy. This is a perfect example of potential energy being converted into kinetic energy. But what exactly is potential energy? Potential energy is the stored energy in an object due to its position or state. In the case of the rubber band, the energy is stored when it is stretched. It snaps back to its original shape because the stored energy is released. The stored potential energy transforms into kinetic energy, the energy of motion. This transformation is not just limited to rubber bands. Think about a ball bouncing after being dropped. The ball has potential energy at the height of its drop, which converts to kinetic energy as it falls. This transformation is what makes springs so much fun. When you compress a spring, you store potential energy in it. When you release the spring, that potential energy is converted into kinetic energy, causing the spring to move. This principle is at the heart of many toys and even some machines. Understanding how potential energy converts to kinetic energy helps us grasp the fundamental principles of physics that govern our everyday lives. Section 5. Keep exploring. In this section, we dive into the wonders of the natural world and the science that explains it all. From the smallest particles to the grandest landscapes, there's always something new to discover. Springs are just one example of how physics is all around us. They might seem simple, but they play a crucial role in many everyday objects and natural phenomena. Whether it's the gentle bounce of a spring in a pen or the powerful force in industrial machinery, springs are everywhere. From trampolines that send us soaring into the air to the shock absorbers in your car that ensure a smooth ride, springs are integral to our daily lives. They absorb energy, store it, and release it, making them essential in countless applications. These coiled wonders demonstrate the fascinating interplay of work and energy. When a spring compresses, it stores potential energy, and when it expands, it releases that energy, often transforming it into kinetic energy. This simple yet powerful mechanism is a perfect example of the principles of physics in action. So, next time you see a spring, remember the science behind its bounce. Think about the forces at play and how this small component can have such a big impact. Springs are not just functional, they are a testament to the elegance of scientific principles. Keep asking questions and exploring the world with a scientific eye. Curiosity drives discovery, and there's always more to learn. Whether you're examining the intricate details of a spring or the vastness of the universe, never stop exploring. The world is full of wonders waiting to be uncovered.